So here we are. I'm sitting with the man, the myth, the legend, Johnny Gilbert.
In the house.
Who are you, Johnny?
I'm
Is that a little deep to start?
No, I'm good. I'm good, man. I'm just ponytail guy that makes shiny spinny things.
Shiny Spinny Things. And we are at the headquarters of Shiny Spinny Things.
Yep. We're in the inner sanctum.
Yeah, it's a little hot up here. So thanks, Steve. Appreciate that.
Yep.
Good job.
Definitely Steve's fault.
If it isn't, it's his offspring for sure.
Exactly. It's progeny.
So Shiny Spinny Things.
Mm-hmm.
I mean, how did we even get into Shiny Spinny Things?
I've been like a hot rod kind of guy, motorsports kind of all my life. Started with dirt bikes before I even had a license and car, to drive a car.
Yeah.
First car was like a old school, late 70s Camaro, small block Chevy. Drove it to high school, did burnouts. Got the cops really happy in the town of my little town and whatnot. They were always pretty good, honestly, better than it could be.
Yeah.
Could have been way worse. My dad got me into that side. My dad was also a truck driver, semi-trucks, all that kind of stuff his whole life. So when I was a kid, he'd bring the semi home. Literally 5-6 years old, I'm in there blowing the air horn, jacking around the shifter, screwing around in the semi. So I've been around diesels and drag race stuff since I was yay high.
That's my stepdad and his father were truck drivers. I was a truck driver in the Army. That was my actual job, as a tractor trailer driver.
Nice.
So you came up with obviously a love and passion for motorsports and just anything cool and fast.
Yeah. Oh yeah. So I've been drag racing my whole life. Since I was 16, had a drag race car. Right. Either drive my dad's, my uncle's, till I got my own when I was around 18. Bought my Chevelle, and I still have it to this day.
That's that one.
That's that one.
Oh, okay.
I've had it since I was 18. That's the one. Yeah. Yep. Factory like 71 SS, 402 big block Chevy. Turbo 400 trans, just factory badass little unit,
Yeah.
It's had a ton of different motors and rear ends and transmissions in it over the years.
Naturally.
So that kind of got me into the drag race side and bracket race at my local track, Osceola, Elkhart, Indiana, every Sunday. Friday test and tune, race on Sunday.
Right.
So I got to the point where getting a little older, early 20s. And then
a little older in the
early 20s.
Older,
early 20s. And then, long story short, like around where we're at, this is the RV capital of the world. Mm-hmm. So you're talking camper trailers, race trailers. They build all the RV stuff around here. So my dad helped me, get my CDL. Basically, drove his truck around, took the test. Back in the day, you could do that. Didn't have to go to school for it.
Yep.
You basically go read the paper, answer all the questions, get a permit, then go take the driving test.
Yeah.
Took it my dad's semi, got a CDL. Was driving for a different company at the time. Got to where just asking questions, talking locally, and found a company that needed some contractors. My uncles in Kentucky always had their own semis. Dad had his own semi, driving for somebody's company, right?
Right.
So ended up buying a semi. My dad and I started contracting for a fairly local company here, hauling RV components. So not the camper trailers themselves, but like RV frames and chassis and components and axles and skid loads of parts locally, regional, local stuff. So that got me into diesel trucks, semis at first. So we're working on them, changing the oil, greasing them, changing fuel pump, learning how to, because I was already kind of building engines and dorking around with race car stuff. So I'm figuring out, work on my semi, I can do that. Hurricane Katrina timeframe, like early mid 2000s, came along, and the company asked me, said, "Hey, I need like 15 trucks tomorrow. We got this job, to haul all these frames to these RV guys to haul all these units." But we were hauling the chassis at the time. So I came up with an idea. I said, "I'll tell you what, these frames are like 32 foot long bumper pole frames. I'm like, why don't we stack them all on top of each other, put some axles on the bottom. I'll get a bunch of pickup trucks and we'll hook these things up and just haul them and drop them fast as we can." And we still hauling stuff with semis and things of that nature. So we got up to like 17 trucks counting 2 semis. So it was typically Dodge trucks. I bought a Dodge, and I was a Chevy guy, and I looked at a Duramax. I was like, man, this looks like it looks like a lot going on under the hood, On a semi, it's 6 in a row, right? Turbo on this side, fuel on that side, real simple.
Yep.
So I was used to the, Cummins Caterpillar stuff that we had in the semis. So I bought a Cummins pickup truck, and then working on them, playing with them, fixing them. One of the weak links was exhaust manifolds cracking. Bought some aftermarket stuff that cracked right in the middle. So I hired a guy that had a twin turbo kit made out of Canada, an old school HT3B, which is an old Cummins 855 Cummins reverse rotation turbo.
Okay.
and like a factory HX35 kind of thing.
Right.
I was like, man, that's neat. And then I made my first compound kit for myself just because I seen a guy that had one and wanted to see what I could do with it.
Yeah.
Immediately proceeded to blow the head gasket, so that was fun. I went down that road to figure out how to not do that.
Yeah.
And that was fun. And that just kind of led to the, making twin turbo kits first. Met some good guys, John Link, the old John Link there. He used to do a lot of injectors back in the day up in Michigan. Found a foundry up in Muskegon, Michigan. Started calling people about making manifolds. We drew up basically a casting design. T3 foot at first. Printed it in plastic. So our T3 foot manifold for 24 valve Cummins on the flow bench in plastic flows twice the CFMs of a factory manifold.
Damn.
Like within 5 CFMs. I was like, we did pretty good there initially. Then I had it called around to some foundries. Found the foundry up there. We didn't have the name stainless diesel back then, but I was still making turbo piping kits.
Right.
Wholesale for some of the bigger name companies that I didn't even know I was making them for actually at the time.
Yeah.
Just going through some other people around about, so that's another story. But long story short, found the foundry to talk to me up there, Muskegon, Michigan. Mark and John, good guys, just off to the races. And then as soon as we had a manifold, I was thinking, man, we should maybe name this thing and figure this out.
Right.
Because all the stock manifolds were cast, and I just stainless manifold, stainless diesel. It just kind of went that way. So my daughter's 19 now, so literally designed that casting and had it cast at the first prototype before she was born. So that casting's been around for 20 years.
Damn. That's a lot of manifolds.
Yeah.
Now, is that...
2025. Yeah, so yeah, been a minute.
Are those still the same folks making it over there?
Yep, same foundry from the beginning does it. We didn't machine them in the beginning. We had a partner that we machined. Still to this day, we work with my buddy Shane over there.
Right.
At a local machine shop, hometown boy, and he's a good guy. I've known him for over 20 years. Yeah. Great company to work with. And then we brought it in-house as soon as we moved to the newer building here. We had more CNC machines, just kind of doing a lot more stuff in-house for the last 10 years.
Yeah.
So
manifolds came first. Well, twin turbo kits.
So on fabrication sides, I was TIG welding, designing flanges. That's another thing. Like our turbo flanges are designed for diesel pressure.
Right.
Ridiculous pressure, And then the pipe sizes are a little different, 3.5 and 4 inch pipe and for down pipes and all this good stuff, right? On your compound stuff. We just designed them to take a lot of pressure. Some of the stuff that was available back in the day, really, really weak and bent and didn't. You weld it and it's warped, not thick enough to really hold an edge to keep a seal good. So we designed a bunch of flanges first to complement our piping, and then we did a bunch of piping, and then that led to our spring gate, easy adjustable gate control.
Right.
We do on our compound, that's 300 gated stuff, and then everything just it was necessity. So the work trucks breaking manifolds.
Right.
I'm up at midnight because we got to be at the job site at 4:35 in the morning with a cracked manifold, and I'm sitting here brazing the crack out of a stock manifold. I bought an aftermarket one at the time, cutting edge, super duper, big brand name. Not going to throw anybody under the bus. It's very, very thin in the middle.
Right.
Very thin. And then that's where if you ever hit it with a laser temp gun,
that's where all the heat is.
All the heat's in the middle. And then
because it all compounds in the middle and turns.
It's a cascade effect. So even in racing, like our 3,500 horsepower stainless diesel Pro Mod had a probe in every single port.
Yeah.
Cylinders 1 and 6 are cooler than cylinders 2 and 5. You gain about 100 degrees as you move in. And then the centers 3 and 4 are 100 degrees hotter there. And then when you move out to the turbo foot, it's hotter here than it is here.
Yeah. And
it's so crazy to see it gain that kind of temperature. But every cylinder contributes and then contributes more heat. And then the center is literally the hottest portion. Like in dyno testing, if you just took that header pipe and just made a straight pipe 4 foot long.
Right.
And you were tuning it and you had some boost and you fabricated some things, but you had a long header straight out from the port, and you took all your probes and just measured the temp, they'd be relatively close on a good high quality set of injectors, like within 50 degrees or less.
No shit.
Yeah. But when you start log manifold here, dump it right here, it's interesting.
Yeah, because they're not, they stick out maybe 6 inches from the head. Like it's a pretty short runner. It's probably a little more.
Yep,
but yeah.
short. Yeah.
Yeah, but super short runner on the exhaust side and collects that heat. You guys start making these products, but at what point did you decide, hey, I like racing. I'm already doing racing, but I should do this with a diesel?
Right. So back in my trucking days, we started buying trucks and tinkering around, and I built relationships with guys that had diesel trucks, and I was leasing diesel trucks on. Plus, we bought diesel trucks and trailers and all this good stuff for the pickup trucks to haul these RV chassis around.
Right, hot shotting.
Exactly, hot shotting the chassis to the manufacturers from another manufacturer. So long story short, we were fixing our own trucks, kind of hopping them up. Bad injectors. Okay, who's the go-to for injectors? So we're leaning on the locals. Hey, who do you use here and what's going on? Just building relationships and going to some diesel. There's a couple diesel races. One at Martin, Michigan. When I met the legendary Jim Layden, badass racer, dude drives from Wisconsin with a 12 valve with slicks in the back and a floor jack and puts them on there.
Yeah.
And this dude popped this hood. He's got compounds on it, and I'm staring at this thing. This thing's pretty badass. He's going like 12 O's, like a bracket truck with a camper top on.
Yeah.
And I'm like, 2-wheel drive truck. I'm like, this is badass. I met him. That led me to meet John Link, J&L Machine.
Yeah.
They used to do a lot of injector tips, EDM work. They were up out of between Grand Rapids and Muskegon in that area. A bunch of EDM stuff. He was doing injectors for some big name guys in the industry. Really big name guys in the industry. Out of a small little shop in the woods. And I said, man, this is great. I met HTS Transmission back then, Dusty Hawk. He's an OG back in the day. He used to build transmissions. And back then there was like just a handful of people. Like I only seen, at the time, there's probably 3 to 4 people, maybe 3 people ever building a compound turbo kit, like that you could actually kind of buy and get on the internet and tinker around with. You're talking 20 years ago, right?
Yeah.
Or longer than 20 years ago now, actually. A couple guys out of Canada, one guy out of the US, and it's like, man, this is crazy. It's just, I started looking down that road, and I'm a, drag race guy, kind of a gearhead to start with, and I'm like, I'm going to hot rod this truck. And that's kind of how it started. Built relationships, and then obviously, like, first thing you do is you put some injectors in your truck. You break your transmission.
Yep.
So, and then you get on the interwebs and you look for the tune box. You get with a little Edge juice box. Back in the day, it was a VP truck. Back then.
Get on the message boards.
Get on the interwebs. Get on the
R.I.P. to the message boards.
Hey, so I got on the OG top comp diesel. So back in the day, my name was Jack Diesel. John Jack. I had an Uncle Jack, so it was Jack Diesel back in the day on Comp D, and then just looked and seen, asked some questions, figured some shit out. Dusty built my first transmission with a Suncoast converter because he was, Suncoast was back in the game pretty deep back then.
Right.
On the converter side, Dusty built that thing and it shifted so damn hard. If I had a cup in the cup holder with a lid off of it, it'd blow coffee all over the damn trucks. I giggled till I broke my first input shaft, and I was like, hey, you tone this thing down a little bit. So he toned it down some, but that was a work truck, towing and working it every day. And then I ended up getting like some kind of box S300 thing off the interwebs, put it on, and then it made a little jam, That's kind of what got me
started rolling.
Got me started and rolling, and then I was like, hired the guy with the twin turbo kit. I'm like, man, this is really cool. Got on the interwebs and found, back in the day, they called them S1 and S2 turbos. Okay. So Schweitzer was making turbos. Schweitzer Company and Airworks was 2 of the big turbos, other than whole set. The whole set stuff back in the day. Borg Warner bought out Schweitzer. Yeah. And then they started calling them S200, S300, S400, all that kind of stuff later. But back in the day.
So that's the origin. See, now we get the origin story.
Yeah,
of
so
S200.
It's like a lot of history back then. Yeah. Like how I got into the turbo side. This is how I got into the turbo side, because I started playing with piping and turbos and fitment. And man, this thing's a bastard to put on and off the truck. So how can I make it easier to go on and off? So that's how we got to our bracket. Now I had like 4 different brackets back in the day. Like, man, this one sucks. And you got to take 3 people to hold this damn turbo up, or you got to put a cherry picker in and get the bolts in. It sucks. So it's like, I wanted to try different turbos. I was like, okay, this company's using this kind of turbo, and this one's using that one, and this one's a whole set, and this one's a Schweitzer, and this one's a Borg Warner, and this one's an Airworks. Garrett Honeywell bought Airworks out, so some of the Garrett's turbine wheels come from Airworks. Airworks back in the day had a great turbine wheel, but a crappy compressor wheel. It was funny to watch that marriage come together and how well that worked. And then Schweitzer, got bought out. Borg Warner, did transmissions back in the day and all this gear, transfer cases, all this cool stuff. And then they got into the turbo game. I started playing with all these turbos, and then by putting them on and off a bazillion times on second gens, initially is what it started with. My first twin kit was second gen stuff. Basically got into trying different turbo stuff. And nobody back then, absolutely nobody designed a turbo for compound turbos that I could find out back then. Like absolutely nobody. So that's where the 5-blade came from. I had a 50-gallon drum full of wheels. I want to say 50-gallon drums, more like a 5-gallon bucket of billet prototypes we did. 8-blade, 10-blade, 7-blade, 6-blade, 5-blade. As soon as we got down to the 5-blade stuff, it's like, wait a minute, the data's looking damn good. 6-blade was really good. And then with wheel design, a lot of guys are going small hubs and all that kind of stuff. Back then we tried, basically you raise up the main blades, knocking blades out, changing splitters, bunch of angles. I look at compressor wheels and turbo covers like a camshaft and a cylinder head in my big block Chevy. One complements the other.
Okay.
The best way to explain it is like you can put a camshaft in your LS or your big block or your small block. You're going to pick up some jam. It's going to change your RPM range. It's going to change the sound. It's going to change some things, right? So the compressor wheel, the OEMs design them to be quiet. Quiet, small, minuscule resonance frequency. Put it into a range that you can't really hear, like a dog whistle.
Yeah.
And then to design the intakes essentially to do the same thing, be quiet. And I was like, man, it kind of sucks because if I'm buying a nice turbo, I want to hear this thing. Later in years, we'd kind of design things to be a little more aggressive tonality-wise, kind of like tuning the guitar string in many aspects for some of the newer stuff we do.
Yeah, but I see what you're saying because the camshaft, but then when you add the flowing head into it, it changes the whole operation.
So the compressor cover, I look at like the cylinder head. The compressor wheel, look at like the camshaft. It gives you that power range and that drivability. You get a camshaft with a fat duration, it sucks in the low end, but you got gobs of power up here. Same thing with the cylinder head. You can put a really big cylinder head on it, and it sucks all the way around if it's not on the right cubic inch.
Yeah.
So the volume of the cover internally, the shape of the volute, the location of the map groove, the width of the map groove changes the entire dynamic of how the turbo works and where it works, and on what cubic inch it makes the jam in the low side or the high side.
And that's crazy because we spend so much time talking about the compressor wheel itself that I've never given much thought to the housing.
I'm telling you right now, I pick up 100 horsepower on a turbo cover change.
Really?
On an 80 millimeter unit. No problems.
And it's because when you talk about the compressor wheel, there's so many things that you can change, right?
Oh, tons.
Like
it's endless. Right. Absolutely endless. Yep.
You can spend billion years playing with those
combinations. And again, that's why I think about it like a camshaft, because you can shift the power lower, you can shift it higher, you can make it real torquey, take the torque out, make it high horsepower. You can do crazy things with the compressor wheel. And as long as you understand like the airflow and what it's doing, why it's doing it.
So where did you get that education of airflow dynamics and whatever, what that would even be called?
So back in the day, when I was getting the manifold stuff figured out, I was doing piping kits and I was using box style turbos, right? Back then, the billet wheels were definitely not as prevalent 20 years ago in what we were doing in the units we were using, right? Everything was a cast wheel. Huh. Everything, very, very rarely was you getting a billet compressor wheel combination, right? Especially a custom gourmet one. There were some out there for old school stuff. For like some of the import guys. There's tons of different import stuff, right? Yeah. So they were kind of getting into that with TO4Bs, TO3s, TO4, all the 3s and the 4Bs, and all the old school. You're talking you're talking Honda VTEC stuff, you're talking DSM, so you're talking old school, right? And I was around watching some of that stuff come up, and then I had buddies that were doing some of that shit, but I never got into it. I was always, big block, small block Chevy, just kind of old school. When we got into designing stuff, there was nothing available. Again, just like the manifold, there was nothing that wouldn't crack.
Yeah.
With thermal heat cycling, right? So we found a company, manifolds out of 400 stainless, it's magnetic, but it handles a ridiculous amount of heat cycling. Like you're not going to crack it. Unless it wasn't heat treated right, or say somebody tried to hook 2 chains to it and maybe pull a bulldozer with it. I still think it'd pull a bulldozer. Pretty good without breaking, but it's just a strong mean piece.
Yeah.
So we were trying to figure out what to do, how to do. So I start researching gas stands. And there was a couple knuckleheads on the internet that had these turbos running on a gas stand just to kind of run and make a turbo run on a little apparatus on propane or something, right? And then I was like, okay, well, if they do that, then how do they read pounds per minute and CFMs? And this, because everything's in pounds per minute, which you can convert to CFMs, and it's just a conversion table. Then I start reading SAE testing criteria, because there's testing criteria for SAE turbo testing. There's actually a couple levels of it for different OEM specifications, how to test and what to do.
All right.
So start digging into that. So I start going down this rabbit hole, literally a rabbit hole for a very, very long time, over a year. I'm like, you know what? I need to figure this out. Nobody's making a wheel for compounds. There's got to be a way to make this thing more responsive, more faster, flow better at the partial pressures that we're dealing with. Because in a compound, like your manifold charger in an atmosphere charger, when you're feeding air into a manifold charger, it's like a 2-stage air compressor, compounding, right? Manifold charger slows down anywhere from 20 to 30% generally, if you're reading shaft speed and you're watching that kind of stuff. And we've got kind of some formulas that we've developed over the years based on hard racing data acquisition, and why we do what we do is based on hard data.
Yeah.
And then we take our static testing, hard data, dyno data, and put it dynamically tested, put it in the world, get it out in the world. Tow trailers, go at high elevation, go at low elevation, spray it with nitrous, do all this crazy things.
Yeah.
Find the rev limiter, find the point at which the engine valve springs start floating, essentially where the weak points are, and then dial it back. Take it to 11, bring it back to 10.5.
See if it can live there.
See where you can get away with. But in the designing side of the compressor wheel and going down this gas stand rabbit hole, I developed a gas stand. Just straight, took me a year to get it to work. So a lot of R&D, trial and error, essentially.
Yeah.
And then I figured out how to make it run and how to get enough volume into it and different injector nozzles and how to control it. So we could set it at 10 PSI, set it up with CFM flow meters, oil pressure, at this pressure, that pressure, different volumetrics to see, how the bearings would last at this pressure, at this RPM. How many CFMs? If we make a change on the jet with the new compressor wheel or a cover or a map groove and how the airflow goes into it, does that relate to a dyno test? So then we would do it, and I used to say the jet don't lie. If I picked up 10% over a stock box turbo, I'd be like, okay, if this picks up 10%, then I should be this much at the tire. We would take it and we'd validate test it on a chassis dyno or engine dyno and be like, okay, damn, now we're onto something. So if I do this, this, and this to the wheel, it picks up. I can make the wheel so aggressive that the turbine wheel size can't drive the compressor wheel. So I'm like, okay, that's neat. Again, coming back to that 5-gallon bucket of parts that we learned on. And this is a very expensive endeavor, by the way. Back then.
Especially back then, yeah.
Back then was ridiculous to even find somebody with a 5-axis that would consider doing what I wanted them to do and then repeatedly do one-off shit. That's kind of how it went. And then slowly, methodically testing things, different blade counts, different things. And the best way I can describe it, when we got to the 5-blade geometry, what's really wild is that on an XY graph, like your normal log on a data log, you have an X and a Y, and say that you had pressure versus RPM. Okay. Real simple graph. That's typically like a normal turbo graph, right? So you have speed and pressure. So it's a little more nuanced on an actual turbo map. We got to the point where 7-blade stuff and the OEM stuff, 8-blade, 7-blade stuff at the time was right there, OEM base. It was really linear. Speed for pressure and CFM. So it's really linear line. It's like it's a 45-degree diagonal from the base to the top. So the more pressure, the more speed, the more CFM, essentially, until you get to the choke line of the turbo. And that's a whole other kind of level. Typically, sonic choke happens if you take the exducer of a compressor wheel, and when that reaches the speed of sound, 720 degrees, depending on barometric pressure and temperature. It gets a little deeper than this, but I'll keep it down to the normal situation. When it gets to that speed at the exducer tips of the compressor, falls off like a rock. Sonic choke happens, so it just literally can't go no further.
It just goes over
done.
the hill and it's done.
But it's relevant to the speed of air off the exducer and the exducer size at a given shaft speed, and it gets a little more nuanced than that, but that's the best way I can describe it. Why a compressor wheel at a high shaft speed does a certain thing, and it just quits. It's mainly about airflow and air at speed. You hit sonic choke.
You're going through this testing. At what point, when you stumble across the 5-blade design, what are the things about it? What is the data that it shows you that really ignites that spark in your head of, hey, we've got something here?
Yep. So basically, back in, get the gas stand running. We get some rudimentary, some basic great sensors that we can rely on. And what I mean by that is we had something called a pitot tube. It's basically like it's a long way to read airflow. It's basically we calibrated it to a 6-inch diameter pipe. Put it so many feet away from the air inlet to an outlet, and it's calibrated for CFM. So we put it on there. We had pressure data, speed data, oil pressure, and then basically CFM. So we're like, okay, if we're going to make a change, let's see if it goes up or down in flow rate. Okay, cool, let's do this. And we started with compressor wheel. Well, actually, there was a couple cover designs we were interested in to see if they flowed more, because there's larger ARs or smaller ARs.
Yeah.
There's a lot to that. It's even more nuanced than that. without getting too off the rails, but certain size compressor ratios, or the air ratio, the AR, like a smaller cover AR with a certain size compressor wheel.
All right.
When you get to a bigger compressor wheel, it wants a little bit more AR to take. It's just kind of like a small block Chevy. You want to turn 8,000 RPMs, you need a little more cylinder head. You need a little more camshaft. So as the applications advance for like flow rates and application, the dynamic changes with compressor wheel size, obviously, and then like the design of the turbo cover. So we did some testing back in the day, started with covers, and that was some of the easy stuff. And then the more nuanced high dollar testing came after that. So we figured out a lot of cool tricks with compressor covers first. And then we're still learning on compressor covers today, which is out of control. Still, there's a lot to be had there, and it's interesting, coming soon.
I'm gonna go grab one downstairs and stick it on them twins out there, and we're gonna figure something out real quick. We're gonna learn.
Oh yeah, there's some cool shit. So when we got to the compressor wheel, playing with it, right? So you're taking wheels, and you're seeing some wheels are taller than others, say in a bore in relationship to the map groove, right? The splitter would be like your half blade, right? Your normal secondary compression stage. Some are like flat, some are angled down, some are angled up. The dimensions from the inlet inducer to the exducer change. That ratio is huge. There's a million different things you can change. So like I said, I ended up with a 5-gallon bucket of things that didn't work so good. And it felt like a 50-gallon barrel when we were done. We started playing with different blade counts, 8 blade, 7 blade. We did a 10 blade, which is actually a 20 blade.
Right.
And there's some OEM stuff that was high blade count, stuff like that on like stationary gen sets that were running at a set pressure ratio, or really high elevation stuff has multiple blades on it because air's thin up there, right?
Yeah.
So I started thinking about it because once upon a time I was building carburetors, and we were doing cylinder head porting and all kinds of cool stuff that I played with because of big block Chevy things. So there's a grinding porting bit. It's called a ferrous bit or a non-ferrous bit on a Dremel tool grinder. A non-ferrous bit takes bigger bites out of the aluminum because you can cut aluminum with it, and it takes bigger chunks out. It's more aggressive. So I got thinking, it's like, man, what if we start knocking blades out of this thing, keep the geometry relatively the same? We can drop it in the same cover we already have. Let's see what it likes. So we started doing, we went up in blades first. It was really funny what that did.
Because the thought process probably is more blades equals
more blades, more work. It's doing better at high speed, right?
Yeah.
Nope. Kind of yeah. It changed the dynamic of where it did things and how it did things. It actually took flow away at the peak. Took some down percentage. So you'd think 6 or 8% up. It was backwards from what you thought. So by testing things, especially when you're dynoing, if you think it's going to be the cat's ass in the dyno world, it's like, nope, that shit didn't work.
Yep.
And things you never thought would work, do work. So that's kind of the way it came in dyno testing and doing all this crazy stuff, right?
It's a race in a car.
So it's yeah, exactly. So it's like, man, damn, I didn't think that'd work, but I guess it did. So it's stuff like that. So it's a shit ton of trial and error, with my White Pigeon High School education, But I tried things, and I was willing to push the limit and go for it. At the time, nobody else was doing that. Put my money where my mouth was with the manifold, and then we started, doing that with the turbo stuff. And it's like, man, I want to figure this out. I want this thing to rock and roll for compounds. So what we found was, once we got to the 5-blade deal, it was really, really, really aggressive in the mid-range pressure ratios. And what I mean by that XY, pressure, RPM, the linear line, 7-8 blade stuff was pretty linear, although it would like teeter-totter at peak and more peak, less peak, depending on what we were doing with blade tip heights and up splitters or down splitters or whatever we were doing to play with that, and hub sizes. But when we got down to the 5-blade stuff, it was drastically different. 6-blade was an increase too. So we went from 7-blade to 6-blade, and that's pretty noticeable. I said, let's try this. We went with the 5-blade, and it was ridiculous compared to a 7-blade.
Yeah.
I was like, wow, why did that work, and what's going on here? So long story short, instead of a 45-degree linear kind of pressure ratio versus RPM curve, when it got to like 28 to 29 PSI, it started putting a hump in the middle. And then it humped up really good between 30 and 45 pounds. It's like, shoot, we had a big hump. And then it kind of continued on to do its thing at about a 8 to 12% peak, depending on the wheel size.
Yeah.
And that was before we started getting into version 2, 3, 4, and 5, and 6 to even up that percentage even more on the initially playing with the first wheel. And I was like, man, that is crazy. And then we just fell on. We tried some stuff and looked at the data. I'm like, man, that's perfect for compounds. Absolutely. Yeah. And then when you weigh the wheel, my 5-blade 80, let's talk about 80 millimeters because it's pretty common size, gas world and a diesel. But a cast wheel 80 7 blade, it's 355 or 353 grams, depending on the wheel
Right.
and
Who
the casting. It's a
manufacturing,
casting,
yeah.
whose it was and whatnot. Typically talking, S4 base kind of stuff. And then when you get into the billet wheel S4 stuff that was still 7 blade, it's actually 5 to 8 grams heavier because a billet wheel has more dense material and it's the same geometry. They didn't change anything on the billet wheel stuff.
Yeah.
That's the billet of the same.
They just made the same
They just
thing
made it out of billet.
in it,
And their design criteria in making it was they put it in like bulldozers and stuff where the air filter would get eroded and it's going to get sandblasted. So it was a resistance to sandblasting. It wasn't for any more power or for faster spool. It's a heavy wheel. The material density is denser.
Right.
It's forged milled wheel, right? So it's forging it. They slam the molecules together and it's the same geometry. It's heavier wheel. I can put them on my scale every week and show people.
Yeah, we just had a video up about wheel weights. And,
Yeah.
So then when you go down the 5 blade, then you naturally lose some weight.
5 bladed 80 is 279 grams from 350 grams on a cast wheel, 355 to 360 grams on a 7 blade billet wheel. So it's day and night, lightweight. So what does that mean in drivability and power? What does that mean?
Well, the flip side is you think about what shaft speed is
Sure.
and 80, 100,000 RPMs,
Sure.
revolutions per minute. So that, it sounds like not a lot. It's 50 grams, whatever.
Sure.
Yeah, but when it's spinning at 100,000
Oh, dude,
RPMs
that's huge.
per minute.
So what happens on engines with lightweight crankshafts? You can turn more RPM
Yeah.
without beating the bearings up. Or you can turn to the same RPM without beating the bearings up. There's less load on bearing system.
Okay.
You can get away with more. Well, here's the thing. Transitional boost response time, say 0 to 5 pounds of boost, quite a bit better with a lighter compressor wheel. And then when you start playing with lighter turbine wheels, like our 9-blade stuff, on the exhaust turbine wheel versus our 5-blade compressor wheel, that's a match made in heaven for a lot of different applications, whether it's VGT, aftermarket, like our GT55 base, 57 base, 400 stuff, ball bearing. Everything you can do to make it wind up quicker is the key right now. You get more CFMs for the size of unit, and that's the technology direction it's going in. But back in the day, you didn't have that. So just putting a 5-blade wheel on a normal kind of unit was day and night difference back then, because it was audibly different, because the pitch was different, more aggressive, unique, and it was a lighter rotor group. So a transitional boost response, transient boost went from, you can go to 10 pounds to 50 pounds twice as fast. It was ridiculous.
Yeah.
So that was a big game changer. But we designed it for compounds. So initial testing was in compounds, and it was great. Temperature discharge air was quite a bit cooler. We dropped 150, 200 degrees size for size on discharge air temps in a compound, which is ridiculous. That's huge numbers.
Just in changing the compressor wheel?
Yeah. Oh, yeah.
That's wild.
So basically, it's recompressing the air at the same pressure ratio, but with less heat. So it's more efficient. And basically more dense air making it through. We're not pissing the airstream off. So it's doing better things.
Well, I mean, that's just compressor wheel side. And then we talk about turbine wheel with the leverage, and that becomes a whole other world of stuff.
It's different. It's different. It gets deeper, with that. Turbo wheel sizes are the ratios between turbine wheel and compressor is huge on a diesel for sure. In the gas world, it's like kind of doesn't. You can go with a smaller turbine wheel in some cases, which is pretty wild to me what they can get away with in the gas world.
Well, it could be on more RPM.
Yep, you got a better volumetric efficiency on your engine, more RPM, better, especially on a V8 versus an inline 6 or something.
Granted, there's a lot of people in the world that just think, oh, well, I need an 80 or an 85 or whatever. But the actual specifics of all of this stuff matter drastically. And even like we talk about now, like I get so hung up, and like everybody does, but the compressor wheel, but the compressor housing, there's a whole bunch of speed gain there that we never even thought about,
Just like a cylinder head. You take a stock head and you put a badass airflow research cylinder head on it and pick up 150 horsepower. It's like, damn, we just did something with the cylinder head. I can pick up 100 horsepower on our cover versus a box turbo cover cut to 80 millimeter.
What can you do on an S366? Bumps.
All kinds of goodies.
At what point did you start, we're doing this research, we're figuring it out, we're making more power, we're doing compound stuff. Kind of funny because we'll get back to compounds because compounds fix everything. Yeah. But at what point do you start taking the diesel racing more seriously? And when do you realize that it has the potential to really...
So basically, I was bracket racing at my local track with my Chevelle. Kind of comes down to that, right? At the time, I had one of my test compound kits on. Had a VP truck. Back in the day, this thing made baby set of injectors is like 550 horsepower. And then I figured out a way we were manipulating some fuel, stock VP pump. We got the edge juice thing. We had a fast exhaust, fast fuel pump on it. had a bigger exhaust, and I started playing with turbos, and I got this combination to make 650 to 680 horsepower. I was maxed out at the stock pump. This thing was rock and roll. And I was towing trailers with this thing. And I towed my race trailer to the racetrack, and it made good power. And I actually figured out how to keep the cylinder head on after 5 tries.
Yeah.
It's another story. So
it takes time sometimes.
It was a train wreck. Not a lot of information back then on how to do it, but it made it do its thing, like 85 pounds of boost. This thing made 689 to the tire, stock VP pump, John Link injectors, our turbo setup, and this is pre-5 blade.
Okay.
Or right about the beginning of the 5 blade stuff, back in the day. Broke the rear end in my Chevelle. This is a points race. I was second in points, and I'm like, well, shit. Threw my tailgate off, threw my hitch off, put a dial in on it, because the thing back then, it would run like low 12s.
No shit.
Yeah, it was like 1220s, 1230s, something back in the day.
Damn.
I was afraid to launch it real hard and break the rear end, or break. I didn't know what was going to break, right? Already broke an input shaft back then, and it was getting it on. So I just like, okay, I want to put a number on the window. So I had this old school trick in my bracket race days. If I could get the left lane, if I put a stripe with my dial in halfway through my side window, put a vertical stripe. As long as I had that bumper at that stripe, I knew I was within about 5/10. So if I put 1305, I would be 1300 if I was in front of this guy, if he was close to his dial.
You bracket racers are a special breed.
I'm telling you, dude.
For sure.
And then in my car, I'm getting like 025s, 030s, 025s. That was my light.
Yeah.
025. And at my local track, if you didn't get a 020 something, your ass is beat.
Yeah, if it's not something.
If you weren't 010, 020, you were done, especially depending on who you were against. I was second in points that year. Long story short, I'm like, I got to go up and get my points. I went 3 rounds in that truck, put 1305 on it, and these dudes would, like, the first guy cut a shitty light because he was watching me puff some smoke out down the track, and his tree came down. He's seen green before he left, and you're way late.
You're done.
You late.
Yep.
And of course, I'm racing these dudes that are like 10, 11 seconds. My Chevelle was low 10s in that modified class, they called it back then. And these guys were laughing their ass off watching me race them because there was 0 diesel trucks doing what I was doing at my local track with that. They just crack them up. Get down to the end. Guys like rolled the window down. He said, my dad's going to kill me, because him and his dad raced together and he was driving it. My dad's going to kill me, beat by a diesel truck. He's way faster than me at the time. So then I just started laughing my ass off. I went 3 rounds in that damn truck. Slow, but fat, but, slow, but good. And then basically I bump in until I almost flickered the top light, because roll out the damn 30-some inch tall tire, right? Roll out sucked in that thing. So I knew what I had to do is go in deep and then flick the top light. And I was like 050s, 060s on a big ass diesel truck back then, which is pretty good. Not used to
and brake boost.
Trying to bracket. Oh yeah, boosting up and getting 15 pounds of boost or whatever, trying to do my thing. So long story short, I went 3 rounds in that truck and I was hooked with the diesel drag racing. It was slow, but man, it was fun as hell. So I started digging and looking for any kind of diesel race stuff. There was an old school race at Indy called DHRA.
Okay.
Back in the day, and it was packed, and there's trucks down there. I went down and had a good time. It was my first diesel race. Actually raced the truck in. Yeah. So broke something the first round and had to go home. Part of the fun.
Yeah. And it's wild to see the succession, because it seems like, wildly enough, I talked to a bunch of people in the diesel industry.
Sure.
I know a bunch of guys have been involved, and it seems like everybody's story almost kind of starts the same. I needed to do something, and then I looked at the truck and I said, screw it.
Yeah, they're at some level.
And then it all went downhill from there.
Common sense goes out of the room, and it's all downhill from there.
And so I guess that's, kind of leads to the VP experience and what you guys do with the Pink Panther and other stuff.
Oh yeah, man, I love that little truck.
I think when I first met you years ago was what was the truck?
Yep, Pro Street truck. Yeah,
the Pro Street truck.
Oh yeah, that was fun and challenging and fast
and at the time, as I recall it, you guys were the Pro Street kings. Like there was nobody messing with you.
Yeah, we were like literally a 482, 485 bracket truck for little. So there's guys that go that fast. They didn't do it for 3 years and win 3 championships. I'm not blowing my own horn here, but I'm just saying there's a lot of one-hit wonders out there that come out and knock it out and quit and then park their shit and talk shit for years. And I ain't going to lie, that's what they do, which is great. And they got a good accomplishment, and I'm happy for them. But we did that shit for 3 years straight at that level.
Four-wheel drive truck.
Yeah, 4,400 pounds, rock and roll. A couple guys have done it a handful of times and parked their shit. Nobody's done it for 3 years in a row. that I know of. Ziegler's coming close.
He's getting
But
there.
he's hammering everybody's ass, and it's great to be partnered up with him. Since UCC did 2365. No, 3365.
No, 33, 36.
Yeah, there you go. But it's been, and even that has been 4 years ago.
Yeah, that was years ago. Yeah.
Yeah, so like he had our stainless steel manifold on, and then he's got our turbo manifold on now, and he is chipping off. He's knocking out 470s and 480s like a bracket truck.
Yeah.
But we were doing it, 19.
Yeah. It was
18, 19, 20, 21.
because I think 19 or 20 was like my first years.
Yeah. We were 19, 20, and 21 in championships and setting the records.
And that
480s bracket truck like a bastard.
That thing was a miracle of modern science because
Oh, dude. One of the first full tube chassis drag trucks on the planet. Full tube chassis 4x4. We were the only one to do it. And we had a lot of people pissed off. Yeah. There was a racing sanctioning body that wouldn't let me race because I didn't have any stock frame rail. And it said must have stock frame rail in their deal. And I was like, how much stock frame rail? Because I saw a piece of stock frame rail out this big. I put it on the frame and tack welded on and sent him a picture. I said, would this do?
Yeah.
He said, nope.
So I remember it was quite an introduction to the stainless diesel crew when I first started coming around. Because I remember you guys were pretty wild.
Yeah.
Would be a polite way to put it.
Mm-hmm. We like to live life. I'm not going to lie.
But then also watching you guys and the thing that amazed me the most always was, not at that time, I wasn't really sure what you guys were doing, but it would be like you'd make a pass and it would go crazy. And I'd be like, and I'd be like,
break the tires loose, sideways, all kinds of dumb shit.
Yeah, and I'd be like, oh yeah, those guys are toast.
Mm-hmm.
But then the elimination rounds would come and it'd be like bing, 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 just right straight down Broadway.
Yeah, we were always testing the track limits and we had some tricks up our sleeve. That truck had so many tricks, it was unreal. So many tricks.
And it also was wired into.
So that's a whole other story. I should really get into
how that thing even functioned.
Just like anything else, right? Back in the day, there's not a whole lot of professional race shops and all this other stuff. So we took my VP truck and put a comm rail in it. And I called the SNS boys. I'm like, hey, man, I want a Bosch. And because back then it was the only standalone. I said, I'm going comm rail. I want a Bosch and I want 3,000 horsepower. Give me all the shit. So they give me pumps, injectors, all the shit for 3,000 horsepower. We put triple turbos on it, and we went racing. Well, we still had a 48 transmission. Lo and behold, that's not a 3,000 horsepower transmission. No. Diesel guys, figuring that out real hard. And then we back half the truck. So out in the shop, I got a guy that built some 4x4, Barney's 4x4 right here local. Hey, man, you got a minute? Swing by my shop. He bought turbos from me. I kind of know the guy. Yeah. This dude built some badass mud trucks and shit that jumps 30 feet in the air and just badass 4x4 from scratch chassis, but big wheels, not like drag race shit. Like, what do you think if we take a look at this truck and do some things? What if we look at this here to do this, and this? Let's 4-link the back of this truck. Give me an 850 cage. He's like, oh, Johnny, I think we can do that. And I'll come over next week and we'll get started on it. I think we can do that. So get it in the shop, pull the back wheels off, pull the bed off, pull everything off. And at the side, we had bed sides on. So we just pulled the stuff off stock frame rail. So we set the jack stands underneath the back of this thing. He's like looking at measuring some shit, and he's walking, goes out to this truck, comes in with a bunch of sawzalls and some shit like that. Just cut the whole back of the truck off. We pull the back window out. We're staring at shit, and I'm like, that's a pretty good start. I guess we're committed now. Yeah, it's too late to go back. So we 4-linked the truck in this 2016. And then the first year we ran it, we went 570s out of the gate back then. And then we got down to probably 550s, 60 range. And then we were chassis limited and blowing tires off and doing dumb stuff. So then bring it in the next year, I think 17 or 18. Took the whole truck apart in the shop, built a chassis table. It's downstairs. Yeah, it's still downstairs. Yeah. Nick's building turbos on it to this day. Built a whole table, took the truck all apart, put the stock frame on the floor with blue tape, plumb bobs, X's, started measuring shit. Okay, I bought, what was it, 1,200 pounds of DoCal R8 tube in Indy, DoCal. So it's just NHRA certified. That's early DoCal. For R8. Yeah, so it's the very first year that NHRA allowed DoCal tube to be used. Yeah. So it's more ductile. It's just as light as chromoly. When you smash it, the sides don't crack. It's more ductile. Yep. It's more strong. It's a little stronger, just as light. And then you can weld it with a MIG or TIG, which is interesting stuff. European tube, that's what they use in IndyCar stuff and IRL and just
They did NHRA
F1. They use it in F1 and all kinds of crazy shit before they went all carbon.
Yeah.
So, but NHRA allowed it one of the first years. We built that truck from scratch on that table.
I didn't know it was R8.
Yeah, the whole truck.
Yeah.
The trick for bending it versus like chromoly is you have to overbend it a little bit because it has a lot of spring back.
It's got a lot of...
Other than that, we were eyeballing some stuff and measuring some shit, put the motor in and put it up. Man, let's set this motor back. We set the motor back 24 inches from stock.
Holy crap.
Swink. We're trying to get that 60-40 weight bias kind of sitting there. We got it.
We got it.
We got it, you know. So, first year we came out with that, we're in the 50s. We got it right at 4,500 pounds, 4,550.
And that was still 48.
48 trans still,
Yeah.
stock transfer case, too much rear gear. That's a whole other story for like too much power, triple turbos and violent. And this is way pre-nitrous. Like we didn't do nitrous until we went halfway through the year of like 19. We got rid of the triples and went big single nitrous. You can never convince me you can have the same horsepower or more with no torque.
Right.
You can't tune the torque out of triples. You just fucking can't. You can pull all the fuel you want, but when you put the fuel back in for power, you got all the fucking torque.
So then that thing
Yeah.
obviously went through some iterations.
Yep. And then with all of the cool technologies and working with the S&S boys, and this was the Bosch back in the day, we figured out we could make the trans live, but it would break the case. I got the clutches to live. I got the fucking shafts to live. I got the band to live. Second gear band would even stay alive, believe that or not.
No shit.
Broke the case twice.
Hmm.
I remember it bright, like clean as day. I'm at Crossville, lined up against Levon in the finals. I spool this thing up. I go in and hit one bulb. He's double bulbing. I can't move it any further to get to the third bulb, and he's burning down.
Yeah.
And I can't go in. I'm like, God damn it. I can't get the third light on. And Lynn's like waving Levon, hey,
Right.
stop. Then my light obviously timed out, and
Red
Levon
out,
goes down and takes the big win. But I went over and talked to him. I was like, dude, I did not intentionally burn you down. I swear to God, I promise.
Right. I just broke
I said,
the
my
trains.
shit is junk. And I'm very sorry for melting your engine down and your transmission because his shit was pissed.
Oh, yeah.
And I know what this shit cost.
Yeah.
Yeah, so that day, I made a phone call. Turbo 400, bam. That's a whole other learning curve, too. Jesus.
So at this point, Levon rides off into the sunset.
Yeah.
Arguably your victory.
My transmission is junk
and
at that point. 48 trans life.
you make the call. It's time
Yep.
for 400. How does that change the program?
At the same time we did this 400 scenario, they changed the weight rule from 4,500 pounds to 4,400 pounds in that range.
Mhm.
So we were like, okay, easiest way to do it is pull two turbos off. At that point, we were starting to try to get into nitrous. We were
Yeah.
trying to do a little bit of nitrous for down track pickups, a mile an hour, all that kind of stuff. What we found out is nitrous makes triple turbos even more violent. And you'll
You don't say.
even go more sideways and you do more crazy dumb stuff. And at the time, like we had to baby it out of the hole and try to backdoor the thing because it would do dumb things if you poured the power on too soon. Partially because of transmission gear ratios and triple turbo things.
Yeah.
And then nitrous makes it worse for drag
What's
racing.
first gear in a 48?
It's a 245-ish.
245.
248 or 245.
Okay.
Yeah, and it's just too much. So it's really close to a standard turbo 400 first gear, like 245, like 140, 1-to-1, right? So we went to a 210, 140 with the trans, and then that was quite a bit nicer. And then at the same time, we did a transfer case scenario because part of the reason why we were breaking the case, we tried to change from a 350 rear gear to various different gears, which also overstressed the case on the 48.
I like how you didn't say what gears. Yeah, I see what you're doing there. All right.
So long story short, the SCS gearbox, you can make whatever gear ratio you want. So as you do that and you stress out the transmission, it applies more stress in doing things and it hurts 48 cases for sure. So we go to 400 and we played with some different scenarios there. At the same time, roughly did single turbo nitrous.
Yeah.
We go test, trans brake, bang, bang. That was a whole other story. Trans brake, low fluid pressure, coming back. We didn't have it restricted right. We didn't have enough charge pressure in the trans. So we had low charge pressure. We didn't know anything about charge pressure in turbo 400s. That's a good portion of that is the thing. We didn't regulate it, didn't know what to do to it, just hooked the shit up and go. Didn't even have a probe or a sensor on it the first time down the track. But so this thing goes like I don't know, 518, 519. Felt like I was on a Sunday drive. The guys on the radio like, hey, what do you think it ran? I was like, man, I felt like a 530 something, 540 something kind of slow. Like I was driving the Taco Bell. It was smooth as shit ever, no pedaling, no sideways, and converter lockup came in, nothing stupid. I was like, man, this is crazy. So single turbo, nitrous, More power, less torque.
Did you guys have a good initial experience with the nitrous? I think that there's
So
a
Steve
point.
had a lot of experience with nitrous, with all of his antics.
Yeah.
So Steve O was my nitrous guy. Obviously, really integrated into the team with everybody at the time, and he was a big driver for nitrous. Man, you need to run nitrous. Man, you need to run nitrous. You know.
Yeah.
And me being a turbo guy, I want to do it all turbo. So that was a big change for us.
I feel like there was a point when the diesel guys really started using nitrous heavily, where like they started to figure out some things that were contradictory to what you would think. But
back then, nobody was using O2 sensors, and Steve was like, "Man, we need to bust an O2 out." We got the Bosch going, we got the O2, and for whatever reason, we couldn't read a O2. I think we came down to the ECM had an issue. We had to send it back to fucking Germany, but we never had a chance to do it. At the same time, we were playing with a whole bunch of other things that were unlocked in the ECM. Ground speed radar, drive shaft speed, linear, shock travels, G meters, inclinometers, yaw meters, all this crazy stuff. We're getting more data we knew what to do with on the chassis side and what we were doing, but we also had the ability to have 7 different tuning tables for traction control. Which a lot of people didn't know about back then because nobody wanted to pay for it or even understood it. And then it took us probably a year or two to even dial it in. But we got to the point where I can go down a gravel road with that thing.
Yeah.
And it didn't give a shit. We're going down 150-degree tracks and everybody's blowing the tires off and we're doing 480s like it didn't matter.
That was the thing. Like I would watch you
Ralph
guys.
was like, "You guys got to figure it out. These other guys don't know what they're doing. They're going sideways and blowing the tires off and trying to blame the track prep." And I'm like, "Dude, power management.
I don't know, man.
It's just doing some stuff, you know." And at the time, we weren't telling the whole world what we were doing, but it was obvious if you knew what to look for and listen to what we were doing. But
maybe people didn't know how either. And,
there's so many. We had so many years of data in notebooks, and we had a couple Bibles that we had for every track and what we did, and every track was nuanced and different. And there's a bump in this lane, and this is. The front half sucks over here, and it's better over here, and the shutdown's bumpy on the left lane, but it's good in the right lane. So all the notes for everything you can ever have for every track we ever went to.
And it worked like a well-oiled machine.
Oh yeah.
Like when I would go
everybody
into the
was
pits,
dialed in on what their position was and what to do.
Yeah.
There was points in time where Steve-O and Roy's like, "Hey, get on your scooter, get the hell out of here. We got this." Just because I would ask questions and just I was getting to the point where I try not to micromanage, but I wanted to have peace in my brain knowing that everything was comfortable.
Yeah.
Because I trust my boys with my life. Because racing things.
Yeah, when you strap in, it is.
One mistake, it's over.
And that's all it takes.
At that level.
Now we start getting to 400 things. We're playing with all this. We're playing with all this
bucket of turbo nitrous stuff. We're getting data, which is really wild. When you bang nitrous to a turbo, your shaft speed goes to the moon. And pressure ratios cause havoc on wheels. Say that you got the shaft speed high enough to not explode and, cause rapid disassembly of compressor wheels and whatnot.
Because you told me there's a point where at shaft speed that the compressor wheels start to actually fold over.
Yeah. Right? So typically there is a pressure ratio that will bend the aluminum. It's it's a forging. It's some good high aerospace aluminum. But everything has its limits and its design criteria. We're trying to make the blades aggressive on its attack angle so it can make pressure. But then you're also making it light enough so it can spool. Yeah. And then the material that we're utilizing is obviously aluminum and aircraft aluminum. And it only takes so much tensile strength. And obviously when you're spinning something 133 millimeter exducer-ish at 127,000 RPMs, there's a lot of forces there. Yeah. You would think that something that massive and heavy could just pop apart and split the wheel down the middle, which they can. Yeah. And the turbine wheel is tremendously heavier. There's a tool steel shaft. There's an Inconel base turbine that's friction welded to it, so that can separate it. The friction weld when you're 2,000 degree diesel heat with a blowtorch of nitrous going on the inducer blades on that. So there's a lot of shit going on real fast. And we're testing them in the diesel world. There is no other motorsport on the planet that has a turbo on it that gets tested harder than a diesel. I don't care what you're doing. I don't care if it's a 4,000 horsepower turbo, big block Chevy alcohol, pro mod, super duper, going 200 miles an hour. If it's a diesel spinning the turbo, gigantic turbo, 125, 130,000 RPMs at 2,000 degrees, that shit don't get tested harder than that. Yeah. It just don't.
So at what point in this nitrous experience, because I think pretty early on, you guys were running pretty clean down track. I think it took people a while to kind of figure out that like you can get really wild in that AFR and make power and it's happy. And
so in the Pro Street truck, we got to go like 8.5 pounds of nitrous per pass, which is a metric shit ton.
Yeah.
We were trying to spray it to the lean side, obviously, to be cooler. We had a big intercooler. We were within 10 degrees of ambient going on air intake temp, AIT,
Right.
which is really good. We didn't have air to water back then or anything, and single turbo. What we realized was we did testing with bigger turbos. We actually did this on one of our 88 millimeters. Everybody thinks we had a 98 like Ziegler and everybody else has nowadays in Cato. Cato runs our 98. Ziegler has our 98. Everybody in Pro Street runs a 98 or bigger in some cases, depending.
Right.
Even in our Pro Mod
stuff. Yeah.
In our Pro Mod, we had a 98. People think we had a 107. We tested a 107 back in the day, or on the Pro Mod, but in the Pro Street, we tested a 98, 94, and 88.
Yeah.
91. What we figured was it's more turbo, more torque. Harder to control the power with more turbo. So we traded turbo size for longevity on the turbo, pressure ratio. Smaller 88 didn't make 100 pounds of boost and bend the wheel.
Yeah.
98s make 100 pounds of boost and bend the wheel. 100 to 105 pounds of boost on a 98 is max ever. I don't even care what the shaft speed is at that point. That pressure bends the back of the wheel, starts tiger striping and bending it up. It's trying to pull itself into the cover. If you don't catch it early, catastrophic failure happens, and that's a bad day for everybody.
Yeah.
So it's all about pressure ratio in a diesel with less flowing cylinder heads. You can be 100,000 RPMs on a car at 44 pounds of boost.
Yeah.
But in a diesel at 100,000 RPMs, you might be 110 pounds of boost.
Well, and the thing that I find that's weird is like we talk about the diesel stuff, the leaner. This is the second time this word we have heard it. That leaner is cooler, but in a gas car, leaner is hotter. So
when you come to AFR, the best way I can describe it, like in my big block Chevy Chevelle, Holly EFI,
lean is hot as
got
hell.
boost, and I'm like 11.5 to 1, 12 to 1, 11.5 to 1, right? So that's nice and safe on a car, but it's still clean and somewhat not black tracking like the nitrous guys running the 10.5 or 11 to 1, right? You'll see a little poof of dark fuel come out initially, but on a sled pull truck, 12 to 1 is black.
Yeah,
like tractor pull smoke like you wouldn't believe. 12 to 1 is that way. That's what it is. You start getting like 18, 19 to 1, you get like a light haze thermal out the stack. But we started like 35, 45 to 1 is not unheard of. We even went to 55 to 1.
Just to try it.
Just to see how. Does it cool it off? Does it not? It doesn't cool it off.
All right.
So 28 to 32 to 1 was typically where we ran in that range.
I've heard
we
that
started shifting it back to richer because I think at some point it kind of cools it off or gets closer to, because you don't want to black track. But 19 to 20 to 1 is red hot. It's hot. We've cooled it off at like 28 to 32 to 1. It's cooled off a little bit, but not much, but it's noticeable. But a lot of guys think that running it richer, a little bit less timing with nitrous, because nitrous increases the burn rate in the cylinder. The best way I can describe it is like you want a peak cylinder pressure, not at the top of dead center.
Right.
You want it to be 13 to 18 degrees after TDC, after top dead center. And the reason why is that if you put your peak pressure burn rate where the piston is straight up and down and it can't go anywhere, it can't do anything. All the energy goes in the piston, burns the ring, melts the top of the piston. It's stuck. It can't do anything. So if you catch it on the way down, it's just over the hump coming down. Give it all the squish bang. That's where all that. That's how you make it live, and that's where the peak power is at.
We're getting all the secrets today.
And then all that data goes further. So the next tier to level is 3,500 horsepower, 3,600 horsepower has been made based on track times, dynos, all this cool stuff with billet and badass engines. The next level is 4,000. That number's 4,000. So,
do you think diesel will ever get there?
Oh yeah, if I had my way, it would have already happened. But
I know
there's some things in place to make it happen already. It just hasn't been implemented yet. But it's coming soon.
It's a challenge because there's we're talking about peak cylinder pressure and the way a compression engine works as opposed to a gasoline engine. And, like
turbo nitrous combos are just really wild.
It's a battle, and I'm not sure. I mean, naturally, it'll probably be a Cummins-based scenario
I think so.
first.
The V8, Duramax stuff's the next one in line to really hit that. But man, it's difficult because you put the same timing curve in a Duramax that you can in a Cummins, the crank will be on the ground. You just can't take it. So you're still injecting, say, 20 degrees after TDC, and you're pushing peak way over, peak cylinder pressure way over to keep the crank in.
And then managing all that injection time, and injection time and timing is a whole other thing we can get into.
Yeah, that's a whole other level of stuff that
Yeah.
I know about. That's why I like my shiny spinny things, and I understand that on a deep level because I spend a lot of money on it in testing and time. But yeah, it gets nuanced like you would believe in the fuel side.
Absolutely. So at this point, I think we're going to carry on into what is going to have to be a second episode, because we haven't even gotten into Pro Mod and Pro Mod Adventures yet.
Oh yeah, right.
There's a whole lot of stuff there, and then there is one question I have to ask before we jump out of here, though, because the people in the crowd definitely want to know. I would like to know. Steve would like to know.
Sure.
So, in a V8 twin turbo configuration, one turbo each side of the motor.
Sure.
In the intake, there is 12 psi. Is each turbo producing 6 psi, or is each turbo producing 12 psi?
So in theory, when you're looking at this, right, you could think about it as a compounding level, but pressure always equalizes. So the compressor outlet from right side bank to left side bank, if you put a probe right at the outlet, it's still making 12 psi to what the intake's making because pressure equalizes. Okay. It's like a big air tank. So your piping and the manifold is an air tank.
Yeah.
And it only gets emptied when the valve opens. So that is 100% pressurized to the inlet. So one's not making 6 and the other one's not making 6, and it's compounding at the intake.
So if we look at the shaft speed.
If you have shaft speed and say this one's like 5,000 RPMs faster than this one, that just means your plumbing sucks on one side versus the other. It's not even.
So if we had that shaft speed data and then went single turbo, would it be the same shaft speed of 12 psi?
Depends on how it's plumbed.
Okay.
Your plumbing side. Like if you had a hard 90 over here and this was canted a little different, and then like your pipe's like 6 inches longer over here, and you lost some thermal dissipation between the header and this because you have longer distance. It's not getting driven like this one.
He's describing my turbo kit right now, in case you're wondering what's going on.
Isn't that funny how I said that?
Yeah.
So I mean, like, if you had data and if you had the stuff, and you're going to see one's faster than the other, but your congealed pressure in the intake is still, say this shaft speed's like slower by 10,000.
So each turbo is still producing 12 psi?
Typically, yes, and it's because you think about it like this. Your pressure is created by the compressor wheel. Like you have your inlet and your outlet, right? So all the work's done in the curve, like bam, bam. The diffuser face is like a garden hose. It's squish. Yep. So the more squish you have, the more pressure, but the less diffuser face squish you have, the less mass flow you have. So that's why some of those diffuser face heights, that's the back plate of the turbo and the back of the compressor cover, which there's a lot of magic in the compressor cover. Yep. So I won't get too deep into that, but essentially velocity, more velocity, less flow, less velocity, more flow. And it's a balance between everything you do. Just like a big-ass cylinder head on a small block. Yeah. Doesn't do shit till you're at 10 grand. So there's a lot of nuances there, but pressure is pressure. Pressure always equalizes.
There you guys have it. Pressure always equalizes. I'll let you guys argue about it in the comments like you did last time.
There you go.
And we'll get a third person on who will tell us a completely different story.
All I can tell you is amass a bunch of probes all the way along it.
Yeah.
And there's your data.
No, it makes sense because in that piping system, like if I can measure the pressure against the wheel,
data don't lie.
12 psi. So that does make sense.
So think about it this way.
The question is it the same shaft speed?
Well,
if it was single, say
if you had the data, which data is king and data don't lie. Say this side sucks at spinning as hard as this side because of piping orientation or whatever, or distance from your drive side and piping orientation. Like a 45-degree bend is always better than 90, and it drives turbo differently, and your pipe size and velocity of the headers, and it gets deep as you want to get. Say you have 12 psi. This one's 10,000 RPM shaft speed or 8 or 5 or whatever, slower than this one.
All right.
Think about it this way. An air tank from this side of the air tank to that side of the air tank is essentially the same pressure once it's pressurized.
Yeah.
Now, because you had an air pump over here and an air pump over here pressing into the air tank,
doesn't mean the pressure in the middle.
Say this pump's working a little better than this pump.
Yeah.
It's still the same pressure at the gauge, and I don't care if you put the gauge off of this side or in the middle.
But what if they're both, for hypothetical sake, both sides are 10,000 RPM shaft speed? They're both producing.
They're both doing within the same shaft speed.
Within the same shaft speed.
Then they're still equalizing pressure. It didn't matter.
Right.
One's working harder than others in some cases, but the pressure's still the same.
Right. But now,
in theory, you could theorize, okay, the compressor map of this one at this shaft speed and this VE of the engine is in theory at this pressure ratio, and this one's in theory at this pressure ratio. But in practical static
You're
testing,
shaking your head like you understand what's
you're,
going on here.
You're dynamically, so if you're dynamically talking about it versus like static testing,
right.
Dynamically, it's the same fucking pressure. It equalizes. This one might be, say this one's putting out 13.5 PSI, and this one's probably 10.5. And it's making 12 in the middle when they come together to make babies.
Yeah.
It's all pressurized back to the inlet portion.
Right. Back to the point of where it's compressing.
It is what it is. One could be producing theoretically more, one's producing theoretically less, but by the time it's doing all the work and pumping into the theoretical air tank, which is your intake and your piping, it's a fucking air tank. Think about it like that.
Yeah. Well,
that's my theory.
I've had my mind blown enough for one day. I don't know about you guys. So if you want to catch even more sitting down with Johnny and the crew at Stainless, make sure you guys share this video, leave a comment, ask a bunch of questions. We'll be asking them all the way throughout. And I'll see you guys next time.
See you next time.
Brother. I mean, I get it.